So for today's activity, we're going to build a couple of real simple circuits that are going to let us generate some voltage signals. And we're going to practice working with the ADC. So the first thing that we want to do is we just want the simplest program you could think of that's going to read out analog pin 0, and it's going to display it to the serial port. And then we'll add a short delay in there so that it just doesn't completely spam the serial monitor. And the first thing that we actually want to look at is, what does this look like? Why do we do that? Or what does this look like if we actually have no serial or no signal connected to the pin, sorry. And what you'll see if you do that, if you look at the serial monitor, you'll sort of see it's going to kind of randomly jump around. So you can see that it started at like 478 and then drop down. It'll eventually settle out at one particular number probably, but it's going to be sort of random. And so this is, we mentioned previously, something called floating. And this is the same sort of reason that we use the pull up and pull down resistors, right? So when there's nothing connected to the pin, there's no positive signal, it's sort of randomly charging and discharging the small capacitance. You're sort of going to get an unpredictable number depending on just sort of the ambient electrical conditions and, trace layout on the board. So after we look at that, the next thing that we're going to do is we're going to use a very simple potentiometer circuit, and we're going to hook that up like this. So we're just going to hook it up so one side of it goes to the 5 volts, the other side goes to ground, and then we're going to hook up the middle of that to our Arduino pin, or our analog pin. And if we look at what that looks like, on our document cam, I stop sharing. Let's get this into focus. Yes.
So the reason that we have like unpredictable behavior is because it's not connected to, like, there's no input that tells the signal like what to do.
Right. So it's unpredictable because it's not really hooked up to a particular voltage or anything. It's sort of like if I hold a wire up in the air and I ask you what voltage that is, well, what does that mean? It's in reference to what, 0, and it's just gonna sort of have like static charge build up. There all sorts of just random electrical signals that are normally very small, but because they're the only thing there, they have time to build up, it's all that you see. Okay.
So the input voltage varies from 1 to 4.
Sorry.
The input voltage that we put through the pin.
So the input volt, so I was asked, what is the input volt? So the input voltage of these pins can be 0 to 5. That 1 to 4 was just a particular example. So it's not going to be exactly 0 to exactly 5. It's going to be a little bit more than 0 and a little bit less than 5. So for that particular example, where I'm just doing a paper initial design, I'm going to pick, something where I'm far enough away from the edges that I'm not concerned about it. But I can then, you know, what you'll actually usually do is have some adjustable resistors in your amplifying circuit so that after you get everything built, you can make small adjustments. I would probably go all the way out to like 0.5 to 4.5 or something like that, right?
Is that called potential that we want to use?
Potentiometers, yes, are adjustable resistors. So yeah, you're going to use those in your actual amplifying circuit. So here's my potentiometer here. I'm not using it for any sort of amplification today. And if so, you can see I just have 3 wires. This is on one side, this is on the other, and this is in the middle. So I'm going to connect my orange wire here to 5 volts. I'm going to connect my middle pin here. That's what I want to go to pin A0. And my ground pin here, or my other one's going to be connected to ground, right? So now if I look at what's going on my serial monitor, because that same program's still running. And let me clear the output. Okay, so you can see that it's nice and steady. It's not bouncing around. It may change like 1, right? Because if I'm closer to the edge of one of those pins or bins, you know, it'll actually be right on the edge there, so it might change a little bit. That's normal. But before you were seeing it was, you know, changing like 10 ADC. So now if I turn the screw of my potentiometer here, which is a lot easier to do with a screwdriver instead of your thumbnail, you can see that it changes the actual ADC value, right? Because I'm reading that out live. And then one thing that you want to do, and I want to point out, is there's actually a few different ways that I could read that pin. So I could use the constant A0, right? This isn't a variable A0 that I've defined. That's something that's predefined already. So that'll read A0. I could call analog read 0, or I could call analog read 54, because A0 is pin number 54. The reason analog 0 works is the program knows that pin 0 is not an analog pin. It's, you know, it's actually like your one of your serial pins. So it knows, it'll make the assumption that when I said pin 0, I meant analog 0, and it'll actually translate that and read out the right pin. So all 3 of those things are going to actually read the same pin. And if I was to call all 3 of them like this, I would see that, oh, I'm going to get the exact same number all 3 times because they're actually each reading the same thing. So once you've done that, you actually want to hook up a multimeter. So I'm going to want to hook up a multimeter here on my yellow pin here. Either I can either go into one of the other holes of the row. That's probably the easiest. I could hook on to the end, poking into the Arduino or the Arduino. And I want to basically take a, 5 or so measurements at different voltages and record what the ADC value for each of those is. And I want to take them in a table. In particular, I want to know exactly when I get close to 0, does that ADC roll over to 0? And you're going to see it's actually going to be a little bit above 0 volts. And when, as I'm increasing, getting close to 5, does that cap out at 1023, right? So one thing you want to remember when you're doing this is make sure you don't forget to connect your multimeter negative terminal to the Arduino ground. Otherwise, you'll get all kinds of weird numbers. And after I've done that, I want to take those numbers and I'll plot them in Excel, and I'll get the equation for a line for that, and then that'll tell me how I can convert that ADC value back into a voltage. So I'm going to want to do that. So, and you'll need to basically have a slope value and an intercept value. I've just used M and B here for the normal MX plus B, right, equation of a line. And I'm going to calculate the voltages based on the ADC value. And I'm going to output that to the serial monitor as well. So if I do that, I will actually be able to have the ADC value and the particular voltage output at the same time. So if I upload that code and I take a look at it, I'll look at what my serial monitor is doing. So you can see I'm getting about 3.24 volts here. And again, if I adjust the potentiometer, I can raise and lower that. So I should be able to go basically all the way down to whatever my minimum value and my maximum value it was. And then for the final part, what we want to do is we're gonna hook up a real simple circuit of, we're gonna have a resistor R1 there. I think this is written such that that would be a 5K ohm resistor, but it's actually not really important what value it is. You should have gotten one in your kit, but in case we sent the wrong one or you don't have it. So we're just gonna have a resistor and a diode. So all we're using the resistor for is we're using it to limit the current. So again, real simple. I've got my voltage coming in here. I've got my diode and I've got my resistor. But one thing that I've forgotten, this diode is polarized, so I've put it in backwards. So that actually wouldn't have worked. Okay, so now I'm looking at whatever this voltage is across the diode. If I look at my serial monitor, I should see a number that's about 0.7 volts, because that's the particular voltage for this type of diode. Now, the reason we're looking at this is we're actually going to use this as a temperature sensor later on. And so now if I actually squeeze onto this diode, I hold it, I'm actually just heating it up with my hand. You can see that voltage changing a little bit. Not much, obviously, because I can't heat it up a bunch, but I got it to change from like 0.72 to 0.7. And if I let go of it, I should be able to make it change. So later on, we're actually going to build the amplifying circuit to make that a full temperature sensor. So that's what you guys should be working on for the rest of today. Try and get all those analog circuits working, get the ADCs reading out. If you have time, it might be interesting to see how each of your analog pins compare to each other. Are their min and max values the same? But that's all we're going to do today.